A soda company has a rule that allows the contents in the bottle to vary by 0.9 fluid ounces from their average 16.9 fluid ounces. Let's take a look at a number line so we can understand this better. In the middle, we would put our average. In this case, it is 16.9. We know that we can step up 0.5, which would leave us at the number 17.4. We could also step down 0.5, leaving us at 16.4. Now with this, we know that our domain has to be in between these two numbers. So we could write this as 16.4 is less than or equal to x, which is less than or equal to 17.4. With this number, we could also write it as an interval notation, which would look something like 16.4, comma 17.4, and this would all be in brackets because both of these numbers are included in our equation. The absolute value inequality statement would look something like this. In this case, the number of steps we could go would be 0.5. We could go smaller than 0.5, but we can't go any bigger than 0.5, which would mean that the absolute value of whatever we're testing has to be less than or equal to 0.5. In the insides, we would put x being the number that we're testing minus the average, 16.9. All of this has to be less than or equal to 0.5. When we're going to put this in decimals, we have to give them a name. So the first one would be f of x, and the second one I'm going to name g of x. When we put this into decimals, it would look something like this. F of x is equal to the absolute value of x minus 16.9, and then we would put g of x is equal to 0.5. And here we see where they intersect. They intersect at 16.4 and 17.4, which, if you recall, are the same numbers that we put our domain at. With this, we can also do f of x is less than or equal to g of x. This highlights the parts where we got our solution. This would be our domain in this equation.